Okay, today we're looking at some of the trig functions, and I'm going to go through these ones a little bit slowly at first, but then there's quite a lot of them, so it'll get a bit quicker as we go on. Right, I'm going to start off with y equals sine x, and I'm going to look at it by the graph. Right. So the graph of y equals sine x looks something like this. Right. Now, remember that when we differentiate, what we're doing is we're actually finding the gradient. Right. So if we've got the graph of y equals sine x, and we're going to use radians for this because we need to make it work. Turns out it works for other things, but in terms of for differentiating, we want to work it with radians first. Right. So we look at that gradient there, where y equals where x equals 0. And it looks something like that. Let's just move that. No. Right, it's on an angle like that. It's not going to let me move that one. And so we know that gradient there, if we draw it on the graph and plot it properly, we'll find out that that one works out to be about 1, or exactly 1, when x equals 0. Right. Then we go along a little bit further. Now we know here it's decreasing. So we can see the gradient is, well, at that point there, it works out to be around about here. And then here, it's flat. So flat is 0. Now the gradient starts going downhill. So it works out to something like that. At this point here, it works out that it's negative 1. Here, it's around about here. Back to 0, and so on, and we end up getting a shape that looks something like this. Now, this will look familiar with the shape above it, but it's slightly different. And where this one here is y equals sine x, this one here, it turns out that dy over dx equals, and this is very convenient, cos of x. Right. And that's really quite useful, that if y equals, that dy over dx is cos x. So we can differentiate it really easily. Anything that's sine of x just becomes cos of x. Now, if we want to differentiate cos of x, so we'll call this one y equals cos x. Well, it's going to start out at 0. Then we have here it's going down. So it's a negative gradient. This point here, it's negative 1. Now it's negative, but it's not as negative. At this point here, it's 0. And we see that this starts to make a pattern that seems familiar as well. Now the scale in these are not perfect. I'm sorry, it's a little bit hard to do them with this tool. Right? And it turns out that this one here, if y equals cos of x, then dy over dx equals negative sine of x. Now we know already that if we differentiate sine of x, it's going to be cos of x, so negative sine of x becomes negative cos of x. And negative cos of x will become negative lots of negative sine of x, so it creates a nice little cycle. And we get this cycle that sine x differentiates to cos x, which differentiates to negative sine of x, which differentiates to negative cos of x, which differentiates to sine x. So we have a nice little circle. And that works really, really well for sine of x and cos of x. So we can have some questions that use those. for example. And all of these will end up using the chain rule, because pretty much everything in calculus uses the chain rule at some point. So we have let's get rid of that. All right, f of x equals 3 sine 2x. Well, therefore f dash of x equals 3 lots of sine 2x times, then we differentiate the inside of it, times 2, so it equals 6 sine 2x. Right, another one, if we had f of x equals cos of x squared minus 3, then f dash of x would be negative sine x squared minus 3 times the differentiating the inside to x, or f dash of x equals negative 2x sine of x squared minus 3. Right. And so those are some basic questions with that. Now, unfortunately, it doesn't stop there. There are some other rules, and some of these are trig identities that you haven't seen yet. So we're going to have a look at some of these. Right, I need to start off by introducing a couple of new rules. So you know that cos is adjacent over hypotenuse, sine is opposite over hypotenuse, and tan is adjacent over opposite, right? Opposite over adjacent, rather. So we know those three. Sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. Tan theta equals opposite over adjacent. But there's three others as well. There's a secant, S-E-C. Secant theta, or sec theta, is hypotenuse over adjacent. Cosec theta is hypotenuse over opposite. And cotan theta is adjacent over opposite. Now what you might notice here is that this is 1 over cos theta. This one is 1 over sine theta. And this one is 1 over tan theta. Okay, so we have these 4 left that we haven't differentiated yet. And you'll see why we're using 4 rather than just using 2 in a second. Or just using tan. All right. So we're going to start off by differentiating tan. Now, the thing to remember with tan theta, tan theta is equal to sine over cos. Because sine over cos is, sine is the opposite over hypotenuse divided by the adjacent over the hypotenuse. And we know that when we divide fractions, opposite over the hypotenuse times the hypotenuse over the adjacent, which means that opposite over adjacent. So that's why opposite over adjacent is tan. Tan is sine over cos. So we can use the quotient rule to differentiate tan. Right, let's have a look at that. So if f of x equals tan x, then f dash of x, well then f of x equals sine of x over cos of x. So when we differentiate it, we've got to use the quotient rule, right? So it ends up this, because we have cos of x times sine differentiated, but sine differentiated is sine of x. Cos of x times cos of x. All right? And then it's minus, and then we've got sine of x times negative sine of x, because sine of x, and then cos differentiating cos becomes negative sine of x. I need a little more room here. Times negative sine of x. All divided by cos of x times cos of x. Okay, now here's another couple of little trig rules, and this is, I guess, a real fundamental trig rule, and it's this one, and it's one that if you think about what it looks like in a circle, it kind of makes sense, but if you haven't seen it, then you just need to trust me on this one, that cos of x times cos of x plus sine of x times sine of x equals 1. And I can show you why in a circle, in a triangle. You can ask me that in class, I'll show it to you. But what we've got on the top here is cos of x times cos of x plus sine of x times sine of x, which is 1. So f dash of x equals 1 over, and we write this cos squared of x. That actually means the whole thing squared. But we write it like that. I'm not entirely sure why. I've always wondered why, but that's just the way it's written. Now that is 1 over cos of x squared, or squared. And if we look up here, 1 over cos of x is sec x. So tan x. So when we have f dash of x equals sec squared of x. So that's the secant of x times the secant of x, or 1 over cos squared of x. Right? I can show you the rules for the other, but what we'll do is we'll actually just put up the table. So if we have f of x, then we have f dash of x. So the basic one that we've already looked at, the basic ones are sine x becomes cos x. Cos x becomes negative sine of x. Tan x becomes sec squared of x. Right. Cosec of x becomes negative cosec of x cotan of x. Secant of x becomes secant of x tan of x, and then cotan of x becomes negative cosec of cosec squared of x. Right, now there's no other option really than just to learn these ones. You can build them all off sine and cos, but really you just need to learn them. And there's nothing more, there's nothing that I can say other than you need to learn this list. They are on page 36 of your workbook. So if you look on that, there's the list of it there written out for you. Probably a little bit neater and easier to read than the way that I've done it, trying to write with my finger on an iPad. Right, let's look at some questions based on these ones. Okay. So, if we had a question like f of x equals cos of x tan of x. All right. Well, cos of x, all right, we're going to do, you're going to have to use the product rule here. Right, so f dash of x equals, so it's going to be negative sine of x times tan of x. Right. Plus, right, now we differentiate tan of x to get sec squared of x. Times cos of x. Now we can simplify these a bit, because we can use the fact that tan is equal to sine over cos to get this. But remember, we don't need to simplify necessarily. It's only there'll be the application questions that we'll need to do it. Right, so we get negative sine squared x over cos x plus, and then we use the fact that secant squared is 1 over cos squared. Cos x over cos squared x. And we can think, well, we can deal with that squared and that, which means we get that f dash of x equals 1 minus sine squared of x over cos of x. But if we think about that, again, 1 minus sine squared is cos squared of x. So f dash of x equals cos squared of x over cos of x. And so f dash of x equals cos of x. Right, that's a very long way around, but that is an option that we could, that's the way we could do that one. All right, because of course cos of x times tan of x, if we had simplified that, would have ended up being sine of x. All right. So either the unsimplified version of negative sine x tan x plus sec squared x cos x, or we could just go for the slightly, if we simplified it, we'd get through to there. Okay. Another one would be one like this. Let's do this in black so we can see this in f of x. F of x 2 cos squared x plus 1. Okay, so we're going to have to use the chain rule here. What we've got effectively, that squared takes precedent. That's the outside bit of it. So f dash of x. It takes a bit of getting used to seeing the cos squared means the whole thing is squared, but that's what it means. So we differentiate the outside first, 4 cos x plus 1, and then we differentiate the inside, times, well, cos becomes negative sine, so we get negative sine of x plus 1. Putting that together, f dash of x equals negative 4 sine x plus 1 cos x plus 1. Okay, so you don't really need to be able to do any more than that in terms of simplifying the trigonometry. You really don't need to be doing much simplifying at all. Okay, last one, let's have a look at this. F of x equals, let's go with a tan squared of x. Tan squared of x cubed. That makes it a little more interesting. Right. So the first thing is we differentiate the outside, so that's the squared. So f dash of x equals 2 tan x cubed. Nope. X cubed. Alright. And then we differentiate what's inside, so that's times 3x squared. Times 3x squared. Alright, which means that goes to f dash of x equals 6. Oh, sorry, we didn't actually differentiate the tan there, did we? So we'll have to quickly get rid of that. Let's get rid of that shadow. Alright. So 2 tan x times, right, we've got to differentiate the tan, which is sec squared x, or in this case sec squared x cubed, and then we multiply it by the 3x squared. So it means we get 6x squared tan, not just t, tan x cubed sec squared x cubed. Alright, and yeah, we could simplify that a few other ways, but that's as good as we need to get. Alright, so that's the way that we do this. This takes a bit of practice and it takes a bit of thinking. It's not something that's going to come automatically, so you do have to do some practice on it. Alright, so the questions. Differentiate this, please. F of x equals sine of 2x minus 3 to y equals 3 cos squared of x, and 3 y equals, let's make it a cosec of 4x plus 3. There we go. There's some work for you. We'll see you in class.